and B, we say A and B are equal only if each element in its place equal to the element in the other matrix. As example, this is P, this is Q. They are equal when these elements are equal to these elements. It means 4 here should equal to X, 0 here equal to Z, Y here equal to 5, 3 here equal to 3. You see? All elements, similar elements, are equal. Now, exercises for you to measure your understanding for the previous one. I ask you to check them and find did you got the concept or not. Now for operation, matrices operations, I will start with addition subtraction. If you have two matrices A and B and you want to add them, A and B, okay, then you see here A and B, I will add identical items. 8 plus 7, 15, minus 2 plus 2, 0, 1 plus 1. You see each items. I cannot add B with C. Why? Because they don't have the same rows and columns. They should have the same rows. The same thing could be said for A and C. Subtraction is the same. Just rather than addition, it will be subtraction. Okay? Also, they should have the same rows, number of rows, the same number of columns. As example here, 8 minus 7 is 1. Minus 2 is minus 4, and so on. Now, multiplying a scalar by a matrix, it means we multiply each element by this scalar. As example, 3 multiplied by here and here and here and here, all elements, as you can see here. You see? We multiply it. 3 by 15, 45, 3 by 0, 0, 3 by 2, 8, 6, and so on. Or if it is minus 2, the same thing. Matrices operation. What about multiplying matrix? Multiplying matrix have more, let me say, details here. Have a look here. This matrix A multiplied by B. By the way, it's different from B by A. First of all, let's specify the size of the new matrix. How many rows here? 2. How many columns here? 4. What about this one? 1, 2, 3, 4, so forth. By. What about this one? 3. Now, condition needs to specify which is the columns of the first matrix should equal, compulsory, mandatory, to the rows, number of rows of the second matrix. If they are not, we cannot do multiplication. Okay? The new matrix, which is C, it's supposed to have number of row of the first matrix multiplied by number of columns of the third matrix. It means I will make it in this way. Very easy. Here rows and here columns. So I have value here, 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 here. All of them. 6 values. How we find it? Have a look. For this first one, I multiply elements of the first row by columns elements. It means 2 by 1, 2 by 6, 7 by 6, 9 by 2. Okay? The first, I got this one. The first row by the second column. I found this one. And so on. I will try with the last number. Okay? It means second row by third column. So 3 times 7, 21. 5 times 1 plus 5 plus. Minus 3 times 1 minus 3. So remove this. 0 by 7 plus 0. So check it, it will give it 23. You see? In this way, how we work. In this way, how we work and find each one of them. You see, I can't find A, B because this condition here is satisfied. But I cannot find BA because it will be 4 times 3 times 2 times 4. And 2 and 3 are not equal, so I cannot do multiplication. This is exercise for you to see how we do the operation. Now next is the determinant. Determinant of a matrix is very useful and important in solving linear equations, in finding later the eigenvalue, eigenvector, in solving differential equations. It's a unique number for each matrix. And we have 3 methods to find. The easy one, which is called combinatorial approach or cross product, simply cross product. The second one is row reduction, and the third one is cofactor expansion. I will start with a small matrix, square matrix. By the way, it should be square matrix, 2 by 2. Now, to find the matrix determinant A, in this way it means determinant of A, magnitude of A. I multiply these two elements, A11, A22, minus A21 by A12, as you can see here. Very easy. These two minus these two. You see? Number. What if it is 3? If it is a 3 by 3, as you can see here, 3 by 3. Now, what I will do, I put my matrix here. I will copy the first row, first column and put it here. And the second column and put it here. So this becomes column number 4 and number 5. Next, I will make a row to say that this element will be multiplied by plus and added. These rows are multiplied and added. These rows are multiplied and added. While here, these rows are multiplied and subtracted, multiplied and subtracted, multiplied and subtracted. Let me show you. The first column here, I copy it. The second column, I copy it. Now, I will do this 2 by 5 by 3 plus 1 by 2 by 4 plus 1 by 3 by 3 plus minus 1 by 5 by 4 minus 2 by 2 by 3 minus 1 by 3 by 3, as you can see here, and do the math. More examples to practice. You see this, I will multiply them, minus these I will multiply by them, as you can see here. This is 3 by 3. You see, I copy first and second column, as you can see here, and I multiply this element, you see, in blue, these elements in blue, and I subtract the multiplication of these elements in red, and the remaining is just merit of calculation. Another example, you see, I copy column 1 and column 2, as you can see here. Then the blue is multiplication with positive, the red is multiplication with the negative, and then they do the math, addition and subtraction. I think it's easy. Now next, I will go to the cofactor expansion, how we find the determinant using cofactor expansion. Let me start with some definition for minor, cofactor, and adjoint later on. Now if I have matrix which is m by n, it means square matrix, then the minor Mij, okay, for I row j column obtained by deleting ith and j column, and then find the determinant for that part. As example, he asked me to find M11, it means minor for row 1, column 1. This is row 1, this is column 1. I delete them. What is left? This part, as you can see here. I do the determinant 5 by 3, 15, minus 2 by 3, 6. Let me change the color. Okay. He asked me minor of row number 1, this is row number 1, column number 2, this is column number 2. What is left? 3, 2, 4, 3, as you can see here. Where is it? 3, 2, 4, 3. Now multiply these, it will give 9. Multiply these, it will give 8, and do the math. Now using this minor, how can we find the determinant? The determinant for this 3 by 3 is, I will do the expansion and using the minor for the first row. Just a minute, you can find it for the second row or the second or third or fourth, yeah, or the first column of the, yeah, you can do it. Any one of them will lead to the same determinant. It will be A by its minor minus B by its minor plus C by its minor. As example, A by its minor, it means this part, you see. And the same thing for B and C. If we apply it here, you see here, 2 minus 3 plus 4. You may say from where it came, this minus. I will show you in the next few slides from where it came when we discuss the cofactor. Okay, Now this 2 by its minor, it will be these numbers 5, 7, 2, 8, and the same thing for others. The remaining is just merit of doing the math. Now definition, let's define the cofactor. What is cofactor? Cofactor defined by this formula would say Cij equal minus 1 to the power I plus j mij. It means the minor of, we just discussed the minor. Example, find cofactor of C11. C11, it means row number 1, column number 1. I will come. C11 equal minus 1, I plus j, it means 1 plus 1, M11, right? How can we find M11? M11, as we said, these elements. Okay, 5, 2, 3, 3. Now, which is equal 5 by 3, 15, minus 2 by 3, 6, equal 9, as you can see here. So, you see here, I do the math. You see the minus, from here it came. Minus in the previous slide I mentioned, it came from here. There is minus in the cofactor. When it is rises to power 2, it go. When it's rises to power 5, it's appear. So odds power will appear. Now, cofactor expansion, it say we can find the determinant by expansion across any row or any column using the formula. I will show you here. He asked me to find the determinant of this matrix A, 4 by 4. Oh, this is complicated. By expanding along the second row. The second row is this row. He's smart because he asked me the second row because here we have zeros, so these elements will go. You see, these elements will go. As you can see here, expansion of A is A21 by its cofactor, A22 is cofactor, A33 is cofactor, 23, A24 is cofactor, as you can see here. The remaining is just substitute. Now this one will go because of 0. This one will go because of 0. What is left? C21. Mean 2. Sorry, C22. This one. C22. C22. I need to find the cofactor for this one. Okay? It will be 3, 6, 1, 0, 0, 4, 1, 1, 3. I put them here, as you can see here. I go for this also, I put it here, but let me focus on the first part. Now for this one, I want to find the cofactor. I will say, okay, I will select to use this row. Okay, why this row? Because I have 2 zeros, so these will cancel. Only what is left on this one. What is left? It's left only these 2 parts. You see, 3, 6, 1, 1. Then I will substitute in the previous formula for cofactor and simplify. I go the determinant. Now, this is how we did the cofactor for each element.